Good day, students. Welcome to math.serve.com, and this clip we're going to be going over problem number 1 of the 2018 AP Calculus AB free response question. This problem focuses mainly on flow rates and the use of tables. If you want to gain access to a wide collection of AP Calculus review material, visit our website at math.serve.com on the AP Calc exam prep. Alrighty, let's take a look at question 1. It reads, grain is being added to a silo. At time t equals 0, the silo is empty. The rate at which grain is being added is modeled by the differentiable function g, where g of t is measured in cubic feet per minute from 0 to 8 minutes. Selected values of g of t are given in the table above. So we have the table given here. Question A. Using the data in the table, approximates g prime of 3. Using correct units, interpret the meaning of g prime of 3 in the context of the problem. Alright, let's start off by taking a look at the formula that's going to guide our problem solving process. Alright, so for, let's say you have a c that's in between a and b, okay, a real number c that's between real numbers a and b, so let's say a is less than c and c is less than b, and this can also be represented using a table. So you have a tabular scenario where you're provided with a and b, and you know that so you have a and b, and you know that c is somewhere between a and b. Okay, so if you have a scenario like this, an interval where c is an interior point, the instantaneous rate of change, or it can also be called the rate of change, which is also the same thing as the derivative or slope of the tangent line at a particular point. The instantaneous rate of change at that interior point c at x equals c can be approximated using the average rate of change. The average rate of change of what? The average rate of change of that interval AB that contains C. Okay? So just keep in mind that the instantaneous rate of change can be approximated using the average rate of change, just as integrals can be approximated using rectangular approximation or the trapezoid rule. Okay? Alright, another notation we can use, instantaneous rate of change or rate of change is a derivative. We're looking at the derivative at a point. So derivative at a point, namely c, can be approximated using the average rate of change. The average rate of change formula is basically the slope of the secant line. Okay? Remember the formula y2 minus y1 over x2 minus x1? Well, that's exactly what it is. Okay? So it's f of b minus f of a divided by b minus a. Okay? So this is the formula that we're going to be using for this problem. Alright, so let's go ahead and solve the problem. So the solution to the problem is as follows. I just took a snapshot of the relevant part of the entire table that we need. So we're asked to approximate the derivative at 3. Okay, so if you look at the table, where is 3? 3 is between 1 and 5 in the given table. Okay, so with this presentation, we can determine what A, B, and C are. So C is the interior point right there in the interval. In this case, C is equal to 3. How do we know C is equal to 3? Well, because 3 is between 1, the smaller one is A, is between 1 and 5. Alright, this is a standard AP Calc AB question where you're asked to estimate the derivative at a point where you're given a table. Okay, so all you just have to do is find the x values that are around that point and use the slope of the secant line through those points to find it. Okay, alright, so we have A is 1, B is 5, and C is 3. So we have all the information we need. So g prime of 3, the rate of change of the function at x equals 3 can be estimated using the average rate of change from 1 to 5. So that's g of 5 minus g of 1 divided by 5 minus 1 is the same thing as y2 minus y1 over x2 minus x1, the equation of the slope of a line through 2 points. We're using this formula here, we're just using g instead of f, okay? Alright, so what is g of 5? G of 5 is 20.5, so 20.5 minus g of 1 is 15.1 divided by 5 minus 1, which is 4. This is a calculator active portion, so you can just plug it in your calculator and you get 1.35. Okay? We're also asked to state the meaning of the fact that the derivative is 1.35. Now we know the value of the derivative. What else can we determine? Well, we have the sign of the derivative. If the derivative of a function is positive, what does that tell us? G prime is positive. Well, we're going to use our fun chart to solve this problem to determine what this means. Now, we have g as a function under consideration. So instead of fun chart, we're going to be using a gun chart. Okay? So we have g, our gun chart right here. G prime, increasing, decreasing. G double prime, positive, negative, increasing, decreasing, positive, negative. Okay, so this is just a grid to tell you the connection between G prime and G double prime. Alright, so we're looking at G prime is positive. G prime is positive. What does that tell us about G? When G prime is positive, that tells us that G is increasing. Okay, so when G prime is positive, G is increasing. When G prime is negative, G is decreasing. Okay, and then if G prime is increasing, G is concave up. That's what the U means. If G prime is decreasing, then G is concave down, and it can also connect it to G double. If G double is positive, that tells you G is concave up. If G double is negative, then that tells you it's concave down, that G is concave down. Alright, pretty cool chart. Alright, so we know that G prime is positive. So G prime is positive, G is increasing. So let's write that down. If G prime of t is positive, so what? If G prime of t is positive, that implies that its antiderivative G is increasing. Okay? So what this answer basically means is that G, which is the rate at which grain is being added, is increasing at this rate right here. Okay, so let's write down the meaning of our answer. The meaning of our answer is at t equals 3, g of x, no, g of t, sorry, the rate at which grain is added. Remember, g of t is the rate at which grain is added, is increasing at 1.35. Now, what's the unit here? The unit of G is cubic feet per minute. Okay, so when you differentiate cubic feet per minute, so you have cubic feet per minute. When you differentiate, that is d dt. Okay, you're dividing it by another time unit. Okay, so another time unit is going to be another minute. So it's as though you're multiplying it by 1 over minute. Alright, so anytime you differentiate, the denominator unit increases in its degree by 1. Alright, so the unit of 1.35 is actually cubic feet per minute square, since you're differentiating cubic feet. Okay, so you see, that's the deal. Alright, so g of t, the rate at which grain is added, is increasing at 1.35 cubic feet per minute square. Another way you can think about this is in terms of velocity and acceleration. G of t is a rate, so it's kind of like a velocity or velocity or speed. Okay. Now the acceleration is the derivative of velocity. So g prime of t is like an acceleration, and we know the unit of acceleration or the dimension of acceleration is length per time square. Okay, and the dimension of velocity is length per time. Alright, so we have length per time, and when we differentiate that g prime, we have length per time square because of ddt's, as though you're dividing by that time unit, which is minutes in this case. Alright, so there goes the answer. Now, how is this scored? On the AP exam, this was the scoring guideline. If you got this approximation correct, that earned you 1 point. Now, if you're able to explain the meaning of this answer with the units, okay, you have to include the units. That's another 1 point. In this problem, you get a total of 2 points. Okay. Alright, let's take a look at the B part. It reads, write an integral expression that represents the total amount of grain added to the silo from time t equals 0 to time t equals 8. Use a right-Riemann sum with the 4 subintervals indicated by the data in the table to approximate the integral. There goes approximation again. Remember, we talked about this earlier, that the derivative can be approximated with the average rate of change. The integral can also be approximated using the Riemann sum, right, left, and middle, or trapezoid approximation. Basically, the area of the rectangles or trapezoids that you put in that region. Okay, so we're doing a similar procedure here. We're approximating an integral just as we approximated the derivative in the A part. Now let's take a look at the formula that's going to guide our problem solving process. Now what you want to remember here is the following formula. Let's just define the following. Okay, let's define the amount added given the add rate. We're just going to define the add rate as a sub r of t. Okay. In rate problems in the AP exam, there is always functions where something is being added and something has been taken out. Okay, so we're just going to call a sub r of t the add rate. Okay, so the amount added given an add rate, the amount added from A to B is given by the formula amount added. So the amount added from A to B with the add rate of r of t. So we're accumulating. Okay, so when you're accumulating, you're going to use the integral. Okay, so the integral from A to B of the add rate r of t dt. Alright, so this integral represents the amount that's added. Okay, accumulating this rate over a period of time. Think about just an analogy, traveling. Okay, if you have a speed and you're traveling at a certain speed over a time period, the distance traveled is an integral, is an accumulation of the velocity times time at every spot in time. Alrighty, so this is exactly the same thing. We're accumulating the rate over an interval, and remember, integral basically means infinite accumulation of subintervals. Alright, infinitely small subintervals. Now, this integral can be approximated. In this particular example, we're going to be using the right Riemann sum with 4 subintervals. This can also be approximated using the left Riemann sum, the midpoint, and also using the trapezoid rule. Alrighty. Okay, let's go ahead and solve the problem. In this particular problem, the rate at which grain is being added to the rate at which grain is being added is given by the function g of t. Okay, on the AP exam, the rate at which material is being added will be given by different notations. Okay, I just use A of R of t as a general formula, and this varies depending on what the problem is. Okay, so let's just make a notation here. This is the add rate. It is a rate, even though it's not expressed as a derivative, it's a rate. Okay, so we know what A of R of t is. Now we need A and B. So it goes from 0 to 8, so that automatically tells us what A and B are. A is the lower bound of the interval, and B is the upper bound of the interval. Alright, so we are good to go. So let's set up the integral that we have here. So the amount added from 0 to 8, the exact amount added can be given to us by this integral right here. Since R of t, we're going to use g of t dt. Now, had it been we're given the g of t function, we can find the exact amount added. But when you're given a table and you want to find an integral, you have to use an approximation. That's the only way you can do it. Okay, whatever approximation method is specified. So this is the exact one. Okay, we cannot do this since we have a table, so we have to approximate using the specified method of approximation, which is RAM in this case, with 4 sub-intervals. Alright, so I have a snapshot of the table here. Now, one thing you want to be extremely careful about is the interval. Make sure you're integrating using the correct interval. Okay, we're going from 0 to 8, so we're going from 0 to 8 here, which is perfect. Alright, so we need 4 rectangles, we need 4 widths, and 4 heights. Let's start with the widths. The dependent variables tells us the independent variable, sorry, tells us the width. So from 0 to 1, that's the first width. So this is the width W of our rectangle. So 0 to 1, how wide is that? That's 1 unit long. And then the next rectangle goes from 1 to 4. I'm sorry, 1 to 5. What's the width there? That's 4 unit wide rectangle. The next one goes from 5 to 6. How wide is that? That's 5 to 6. 1 unit long, wide rectangle. And then the last one goes from 6 to 8. How wide is that? 8 minus 6 is 2. Alright, so we have our 4 widths for the 4 rectangles that we're going to be finding the areas of. Okay, and then we need 4 heights. 4 widths times 4 heights. Okay, so we're going to have rectangle 1, 2, 3, 4, and that's it. Now, but if you look at this is the height right here, okay, of our rectangle. The heights is given by, there are 5 heights, 1, 2, 3, 4, 5. So we need only 4. Since it's a right Riemann sum, that means we're taking all the points to the right of the left end point. So this is gone. This will be our first height, second height, third height, fourth height. Okay, so this will be the height of rectangle 1, height of rectangle 2, height of rectangle 3, and height of rectangle 4. And those we go with 1, with 2, with 3, and with 4. Alright, you can draw it if you want, but it's not necessary. You can just look at it and figure it out. Okay, so let's go ahead and put that in. The right Riemann sum with 4 rectangles is given by the area of the first rectangle, which is width of 1 times height of 1, which is 15.1. That's the first rectangle. Second rectangle, width of 4 times height of 20.5. Plus third rectangle was the third rectangle, width of 1 times height of 18.3. Okay, I moved it down a little bit so it fits. Alright, so let's go ahead and finish it up. And then the fourth rectangle, width times height. The width is 2 times the height of 22.7. So just plug all this into your calculator and you have the right Riemann sum using 4 subintervals of 160.8. Okay? So there goes the answer. Well, what does this answer represent? This answer represents the amount of grain added to the silo from 0 to 8. Do you know what the unit is? For amount is just cubic feet. You weren't asked for that, but I'm just saying it. Okay, so let's talk about points here. How was this question scored on the AP exam? First of all, you get 1 point just for setting up the integral expression. You see this integral expression right here? Just setting that up will earn you 1 point. Okay? And then secondly, if you have the right Riemann sum, this piece right here, if you have that accurately written down, that's another point. And then lastly, if you plug it into your calculator correctly and you come out with the final answer, the approximation, that's another point. This question is for a total of 3 points. Okay? Alright, let's take a look at the C part. It reads, the grain in the silo is spoiling at a rate modeled by W of t equals 32 root sine of pi t over 74, where Wt is measured in cubic feet per minute from 0 to 8. Using the result from part B, okay, so in part B we talked about how much was added. So we're going to use that to approximate the amount of unspoiled grains remaining in the silo at t equals 8. Now this is a typical AP Calc AB question where you have a scenario where two functions are carrying out opposite actions. Okay, one function will be adding stuff to a pile, and then the other function will be removing stuff, and you'll be asked to find what's the amount over a period of time after both functions act on the situation. Okay, so in this problem, g of t is the adder, is what adds grain into the silo, and w of t indicates spoiling, which is the removal. So the spoiling process of the grains is the removal process. Okay, so g of t adds, w of t removes. W of t acts on the scenario from 0 to 8 just as g of t does. Now note, that's not always the case. Sometimes one function might act at a subdomain or subinterval of the other function. It's not always the same. But in this particular case, it's the same. Okay? Alright, so let's go ahead and write down the formula for scenarios like this on the AP exam. So you have, let's take a look at the formula. So they're saying what's the amount of unspoiled grains. Okay, so we're going to refer to that, the difference between amount added and amount removed, as the net amount. Okay, so the net amount, sorry, I'm having some technical difficulties. Anyway, the net amount, basically in amount added minus out, alright, is given by amount added minus amount removed. Now if you're given the rates and you want to find the amounts, then you have to accumulate the rates over the intervals. Okay, so we're going to call the net amount n of t. Okay, The net amount is going to be the integral. So we're basically looking at net amount from A to B. Alright, so that's given by the accumulation of the add rate from A to B. Okay, this is the amount added minus the accumulation of the amount removed A to B of removal rate. So let's call the amount removed removal rate. Okay, so R sub R of T. And also, oh, there's something important I forgot to state. We also have to add the plus initial amount. In some AP exam questions, there was actually some amount there initially. Okay, so that also has to be taken into consideration. So the amount added minus the amount removed plus the amount that was there before. Okay, so we have this plus, let's just call that initial, plus initial. Okay. Okay, now that we have the formula, let's go ahead and solve the problem. Alright, so we just need the functions. So in this particular situation that we have here, the rate at which amount is being added, a sub r of t, is given by the function g of t. Okay? This is the add rate, and then the rate at which function at which grain is being taken out of the silo is w of t. Okay, so this is add rate, and this is removal rate. Removal rate. Okay, so to get the net rate, we're going from 0 to 8. We're going to be taking a look at the following integral. Let me move this down so we have enough space. So the net rate, the net amount that we're going to have is going to be the amount added. So it's going to be the integral from 0 to 8 of g of t dt. This is the amount added. Okay, minus the amount removed, or the amount that's spoiled, which is the integral from 0 to 8 of w of t dt, plus the initial amount. Okay, so how much grain was there at the start? If you go back to the problem, it tells that to you. It says grain is being added to a silo. At t equals 0, the silo is empty. Okay, so this is not always the case. Sometimes there is some amount there before. So at t equals 0, the silo is empty, so the initial amount is 0. Alright, so we're going to be adding 0. Okay, so the amount added, the amount remaining, net amount, let's put that there, amount unspoiled at t equals 8, which is basically the net amount from 0 to 8, is given by, so we already calculated this before using our right Riemann sum. So this is going to be an approximation too, so it's not going to be exact. This is going to be estimation, since one of the components is an estimation. So is approximately, so we're going to grab our previous answer. Now this is a situation where your previous answer can hurt your points in the next question because you're extracting that answer, or if you don't know it. Okay, so we extract the answer that we got from the previous question, which is 160.8 minus, and then we have to evaluate this integral. This is a calculator part, so let's go ahead and use our calculators to do this. So for this particular problem, I'm going to store the function. Okay, you don't have to store it if you want. You can just evaluate the integral directly, but I'm going to store the function because w of t is utilized in part D. Okay, and I have the habit of storing functions because it makes my integral clean. Alright, so let's go ahead and store the function. I'm going to store this function in w of t, so just put 32 times the square root of sine parenthesis, put another parenthesis, sine of pi t. So you have to be careful with your independent variable. Okay, so let's put pi times t here just to be extra careful. Alright, so pi times t, let's put that in parentheses, pi times t divided by 74. So keep in mind that our independent variable is t, sometimes it's x, okay? So you have to specify that when you're differentiating or integrating. Alright, so keep that in mind. Okay, so I closed the sign and I'm going to close the radical. So let me enter to make sure it's complete. Okay, so check your work, make sure your entry is good. Okay, so I'm going to store that in w of t. So store that in w of t. Enter. Okay, so it says it's done. So just to make sure that what I have stored is correct, I'm going to call the function w of t and see what entry it returns. Perfect, that's what I want, 32. Okay, so now we're good to go. All we are doing is looking for the integral from 0 to 8 of w of t dt. Now the nice thing about storing a function is that as soon as the function is stored, you do not have to enter it anymore. All you just have to do is enter the name of the function, and the calculator will do the substitution and evaluation. Okay, so you're integrating this function. Now be careful here. The independent variable is t. We're integrating with respect to t. Don't put x. All right, or you have problems. And we're going from 0 to 8. Okay, and then press enter, and then it returns this to you. So basically all it just did is it's plugged in the function into w of t and then return this. Well, I need a numerical answer. So in order to get a numerical answer, I'm just going to ask for the approximate value of this integral right here. This is the exact form. So the approximate form, just press pound enter as you already know. 99.0515. So that's the amount of grain that's spoiled or that was removed. So minus 99.0515. And there was no amount, it was empty at the start, so that's a 0, that's gone. Okay, so you go ahead and just subtract these two and you end up with 61.749. This is an amount, so it's cubic feet. Alright, let's just write down what the answer means, okay? The problem doesn't ask for it, but let's just write it down just for kicks, just in case in the future you ask to state the meaning of this. So the approximate amount, of what? Unspoiled, the approximate amount of unspoiled grain in the silo at t equals 8 is 61.749 cubic feet. Okay, so that's that. Okay, so scoring guidelines. How was this question scored on the AP exam 2018? Setting up the integral, that was 1 point, and then getting the correct answer, that's another point. In this problem, you have a total of 2 points. Okay. Alright, let's take a look at the last part of question 1. It says, based on the model in part C, is the amount of unspoiled grain in the silo increasing or decreasing at time t equals 6? Show the work that leads to your answer. Okay, believe it or not, this is another typical AP Calculus AB question where you're asked if the amount in a particular scenario where quantity is being added and quantity is being removed, you'll be asked if the amount is increasing or decreasing at a particular point in time. Okay, so as though you have let me just give you a sketch. You have, let's say, a bucket of water, and water is being added to it. Okay, you have an add rate, and then water is being taken out of it, or let's say it's leaking water, and this your removal rate, and then you're asked to determine if the amount of water is increasing or decreasing at a particular point in time. That's a typical AP Calc question. Okay, so let's go ahead and take a look at the formula that is going to guide our problem solving process. So formula is as follows. Now, increasing or decreasing net amount. Okay, so we're looking at the net amount here. Why are we looking at the net amount? N of t. Why is that? Well, we're told based on part C is the amount of unspoiled grain. How do you find the unspoiled grain? The amount of unspoiled grain is the same thing as the net amount. Why? Because to get the amount of unspoiled grain, you have to subtract the amount of grains added. The amount of spoiled grains from the amount of grains added. Okay, so the amount of unspoiled grain is equivalent to the net amount. All right. So increasing or decreasing net amount N of t is equal to what? Now let's freeze for a second. How can you tell if a function is increasing or decreasing? Now we talked about this earlier. We used the gun chart, right? So here we're going to use a non-chart. So if we have n, concave up, concave down, n prime, increasing, decreasing, n double, positive, negative. So when n is increasing or decreasing, n prime is positive or negative. Okay, so that goes your non-chart. Bottom line is this function right here in the first column can take on different names. Okay, the standard name is fun. I call this the fun chart, but it could be non-chart or gun chart or whatever chart that you want to call it. So in this particular scenario is a non-chart. Now look at this chart. How do you know if n is increasing or decreasing? Whether n is increasing or decreasing, also known as the behavior of n, in order to determine that, you want to look at the sign of the derivative. So the sign of the derivative of a function tells you if the function is increasing or decreasing. So the sign of n prime, whether positive or negative, tells you whether n is increasing or decreasing. Okay, so back to our formula. The increasing or decreasing net amount, n of t, is basically determined by the sign of the derivative of t at a particular point. Okay, so the n prime of t. Alright, so now that we know how to set it up, we want to crystallize the formula further by expressing explicitly what n prime of t is. Okay, so we know what n of t is, right? So n of t is basically the amount added minus the amount subtracted plus the initial amount. So amount added is the accumulation of the add rate, okay, from A to B, minus the amount taken out. So let's be, okay, so minus the amount taken out, or yeah, so the integral from A to B of the removal rate with respect to time, and then plus the initial amount, right? Okay, so this is n of t. This shouldn't be new to us because we use this for part C, right? This is what we use for part C. Now this is n of t, the net amount, but we're looking for the sign of the derivative of the net amount function. So what do? We differentiate this function. Okay, so let's differentiate. So n prime of t, if you differentiate this right here, this becomes, you have the amount AR of t, because the derivative undoes the integration, minus the removal rate, or R of t. And then this initial amount is a constant, it's like a number, okay, like 0 cubic feet. If you differentiate a constant, that goes to 0. Okay, so basically what this tells us that is that if you want to determine if the net amount is increasing or decreasing, all you simply have to do is find the difference between the add rate and the removal rate at that particular point. Okay, so just take the add rate and then the removal rate, plug in the value that you're looking for, and then subtract, and that's it. Let me show you how that applies to this particular problem. So let's go ahead and solve it since we have the formula that we need. Alright, so increasing or decreasing of net amount at t equals 6. So that's going to be determined using the derivative of the net amount n prime at 6. So using this formula right here, which is going to be the add rate is g of t, right? We already know that. So that's going to be g of 6 minus the removal rate, r of t, is w of 6. Okay, so that's all you do. Just plug in the time value into the functions, into the rate functions, and then you subtract them, and whatever the sign is, because that sign is a net rate, okay? So whatever the sign of the net rate is, that will tell you if the net amount is increasing or decreasing. Okay. Alright, so how do we do this? To find g of 6, you simply use the table that's was given to you. So let me show it to you. So the original table, g of 6 is 18.3. Okay, so that's pretty straightforward. So let's put that in. G of 6 is 18.3. And then we'll subtract w of 6. What on earth is that? Well, w of 6 we have stored in our calculator already. So guess what? We don't have to do any work. We just simply do the following. Since w of t is already stored in the calculator, all you do is you just enter the function w of 6. So what this is going to do is it's going to substitute 6 for t in the function. Let me press enter. So you see here, it replaced the function, it replaced t with 6 in the function, and then it's simplified. But we need a numerical answer. To get a numerical answer, we press pound enter, diamond enter, and then we get 16.0632. Alright, so 16.0632. Okay, so this is the rate at which grain was being added at t equals 6. This is the rate at which grain was being removed at t equals 6. And the amount, the initial amount, doesn't play any role here, so that's why it's gone. Okay, so when we subtract these two, the sign of that answer is what tells us exactly what we need to know. So when we subtract these two, we end up with 2. I forget the answer. Let me put it in a calculator. So we have 18.3 minus this answer here. Oh boy. So it's 2.2368. Okay, so this answer is positive, is greater than 0. Now that's what we need to know. Alright, so let's go ahead and tie everything together. So how is everything connected? Well, first of all, before we write down what the answer is, the sign of the net rate, or the the sign of the net rate, or the behavior of, no, the sign of the net rate. Where's this going? Now, since the sign of the net rate is positive, that tells us that the net amount is going to be increasing. Okay, net rate at t equals 6 is positive, so the amount is going to be increasing at t equals 6. Alright, so let's go ahead and write down, since the net rate at t equals 6, which is equal to n of 6, n prime of 6, which is given by g of 6 minus w of 6. Since the net rate is greater than 0, positive, what does that tell us? It tells us that the amount of unspoiled grains, the amount of unspoiled grains is increasing. Okay, so the derivative is positive. That means that the antiderivative is increasing. It's increasing at t equals 6. All right, so let's look at the scoring guidelines for this problem. Now, if you just write down this equation right here, n prime of 6 is equal to g of 6 minus w of 6, and you take a look at the sign, then you are going to earn yourself 1 point. Okay, so setting this up and looking at what the sign is earns you 1 point. And then if you explain what the significance of the net rate being positive means, basically it means that the amount is increasing, then you earn another point. In this particular problem, you earn a total of 2 points. Thanks so much for taking the time to watch this presentation. I really appreciate it. If you found the contents of this tutorial helpful in your preparation of the AP exam, do give us a thumbs up. Your positive feedback is very valuable to us. If you have any questions or comments or requests concerning in connection with this presentation, just post it in the comment section below. Do not forget to subscribe to our channel for updates to the remainder of this AP Calculus FRQ solution. More videos, practice games, worksheets, and resources can be found at mathgotserved.com. Do check it out. Thanks again for watching and have a wonderful day. Goodbye.